Now let's look at 2024 AIME II Problem 2. This problem asks us to determine a list of numbers satisfying the given three conditions. So first, the sum of items in the list is 30. Second, the unique mode is 9. Third, the median is an integer, but it doesn't belong to this list. So let's look at the first and second conditions. We know that there's a unique mode that is 9, right? So that implies that 9 must appear for at least 2 times. And the sum of items is 30. So it tells us that the number of occurrences of 9 is either 2 or 3. Okay? And let's look at the third condition. So how do we know that the median is not a number in the list? So it tells us that we must have an even number of items in the list. Otherwise, if it's odd, then the median actually this is the middle number, right? So we must have an even number of the items in the list. And in addition to it, so the median is equal to the average of the middle two numbers. And how we make sure that it's a positive integer? That tells us that the middle two numbers must have the same parity. Okay, let's use all these observations to determine this list. So let's look at the 9. Suppose 9 has occurrences that is 3. Then it tells us that the sum of the remaining items in the list should be 3. So first, we can't have 3 ones. Otherwise, both 1 and 9 are the mode, right? So 9 is not a unique mode. What about writing 3 as 1 plus 2? So in this case, we have 3 9s and 1 1 and 1 2. So we have 5 items. It's not good because recall we need to have an even number of items. So it tells us that 9 cannot appear for 3 times. So 9 must appear twice. And the sum of these two 9s is 18. So it means that the sum of other items should be equal to 30 minus 18 is 12. Okay? All right. And don't forget that we need to have an even number of items. So now we need to find an even number of items such that their sum is equal to 12. So would it be possible that we have 4 such items? So first, because 9 is a unique mode, it appears for 2 times. So it means that every other item should appear exactly once. So all other items are distinct. Okay? So suppose we have 4 such items and they are distinct. How can we get the sum of them is equal to 12? So one possibility is we have numbers 1, 2, 3, 4, right? Or 1, 2, 1, 2, 3, 4 is not valid, right? So it should be 1, 2, 3, 6, right? Or 1, 2, 4, 5. So only these 2 possible scenarios. But are they feasible? No, because recall that we require the middle 2 numbers to be with the same parities, but the middle 2 numbers in both scenarios have opposite parities. So none of this is feasible. Okay, so we can't have 4 additional terms beyond 9 and 9. Can we have 6 terms? No way, because for 6 smallest numbers, the sum of them from 1 to 6 is more than 12. So to get a sum of 12, we must have 2 additional items. So now we need to look for 2 items such that the sum of them is equal to 12. Okay? All right. So this brings us one thing. So whether the larger number is bigger than 9 or is smaller than 9. Suppose the larger number is bigger than 9. Okay? Then what about the order relations of all these numbers? We sort them in the increasing order. So if at the smallest number, it is followed by 2 9s. Then we have a bigger number. So the small number is equal to 8. The bigger one is 12 minus 8. Is it feasible? No, because the middle 2 numbers are 9. So the average is 9. The median is 9. It's not okay. Okay. So basically it tells us that 12 minus 8 cannot be bigger than 9. Okay. So 12 minus 8 must be smaller than 9. So we must have that the smallest is 8. Is followed by 12 minus 8. Then the 2 biggest numbers are 9s. So in such a pattern, then The median is the average of the middle two numbers, 12 minus 8 and 9. Okay? So recall that we require these two numbers to be with the same parity. So then we know that 12 minus 8 must be equal to 7. So A is equal to 5. Okay? This is the unique solution. And this problem asks us to compute the sum of the squares of all items in the list. So the answer is 9 squared plus 9 squared plus 5 squared plus 7 squared. It is equal to 236.